Hi, my name is Joseph La, a Vice President at POSCO and Head of Corporate Strategy at POSCO Europe in Frankfurt. Hi.
My name is Huib. I'm Head of Marketing for the engineering sector at Tata Steel in the Netherlands.
Tata Steel and POSCO, we are two of the biggest steel makers in the world. And for us, if you look at where our plants are located, we're about 9,000 kilometers away. But we believe that one day we'll see Hyperloop connecting the two of us. And for that, we wanted to work together so that we can actually support the commercialization of Hyperloop. Last year, in I think the first Hyperloop conference, there was a speaker who mentioned that it's smart vehicle but dumb infrastructure. We disagree. And on that point, we have been working together for more than 2 years now, and we have the first results, and we would like to share that with you today. Hyib?
Indeed. So as Joseph mentions, how it started was 2 years ago when we discussed about when the Hyperloop promoters start to think about their future technology, which is still far out, then they shouldn't think about the materials or the technologies of today. They should be thinking about the materials of technologies of that will be available by the time that the Hyperloop tracks will be built. And also for steel, that means that a lot is possible still to improve and to make significant improvements towards the Hyperloop demands. So our first question, and we partnered with Hard Hyperloop, and our first question to the Hard Hyperloop engineers was, what exactly does a Hyperloop tube need? What are your requirements? And their first requirement was things that you've all seen, you know, low air pressure, and it needs to, and then that was not enough. That's not enough to develop a material. So we said, no, we asked again, so what really do you need? And that became a much more lively discussion. And what you can see here, and I won't go through everything because we only have a small time, but you can see, for example, we split between what is needed during operations and what is needed during assembly. And those are two different stages of the life cycle of a Hyperloop track. And we collected as much detail as we could get the demands from the Hyperloop team. So what will it take? And we started thinking, what can we do through the material? And of course we have a close deadline because the Hard Hyperloop team is ambitious, like all the Hyperloop promoters, and they want to build the European Hyperloop Center. And we wanted, of course, to have the best steel available for this moment, to develop that for the European Hyperloop Center. So we finally concentrated on the 3 items on the right-hand side to make sure that the steel that's used for this track provides long-term durability and safety, is the best in machinability and in weldability. And that's when we moved to the next stage.
Where the new steel grade development was that. Now, with the 3 items I identified, we targeted the specific characteristic that we wanted to improve, which was damping properties, and second, yield ratio, and then third, improving the CEQ, which is the weldability. Now, the development, how it started and what the progress was that from the engineering side, when they talk about the structures, from our side, we are the materials provider. So we are translating the engineering words to material. And from that, considering the chemical compositions, heat treatments, or microstructures, we were able to develop a new steel grade, which has improved safety with about 1.6 times better performance in damping, and then 4.7 times in low temperature strength. So regardless of whether it's in deserts or in cold regions, it will secure more safety there. And then the second was the easy machinability, where we were able to lower down the yield ratio by about 10%. So for there, it will facilitate better machinabilities. And lastly, easy weldability, we were able to improve about 5%, but we let that stay because we wanted to have it coincide with other materials or in other connections. So it's the same weldability, but it performs a little bit better, and we were able to secure all the weldable solutions with it. Now, within this progress, it's easy to say that this has been done, but in fact, it's a multi-million-dollar process. From the lab, from the idea stages, numerical analysis, lab production, lab test, and then actual real full production, and the full structure test. So we were doing little sample tests, but we were also doing real large diameter structural tests. And with that, we are able to share this result. Hyib?
Indeed, and we're proud to say that in time for the delivery to HART's Hyperloop Center, we actually provided the steel on time. I brought a piece of this sample today, a bit enlarged on the screen so you can see it. But this is the world's first Hyperloop steel grade, developed specially for Hyperloop and designed to meet the detailed aspects of the Hyperloop tube. We're very proud to have done this. The tubes are being manufactured as we speak, and will be transported back to the fabricator, where they'll be welded with the tracks, etc., to be built.
Mm-hmm. And I heard today that actual first pipes have been delivered today. So it's here in Netherlands. Excuse me. Now, while we're doing this, we're not just developing the coils. We're working with the pipe manufacturers so that it can be actually produced. So with the tube manufacturers, we're doing the same processes and also optimizing the welding parameters, and then welding consumables, and then all the welding procedures have been developed and have been shared and tested with the pipe manufacturers. And now the pipes are here in Europe. The ones being produced in Europe is finished and will be delivered to our tube manufacturers for assembly in 2 weeks. Right?
So that's the real news of today. That's what we wanted to bring to this conference as well. But you might also be interested in what's next. So the engineers are not ready, and they're not happy yet either that they've done everything that's possible. A lot more is possible. So first, what is the real objective? It's to achieve the sustainable and smart infrastructure by optimizing the weight and material usage. Because I think between the world of mobility and between the world of steel, there's some things are really in common. And one thing in particular is we're both part, if you look at climate change, we're both part of the problem because of the CO2 that's involved in mobility and the CO2 emission that's involved in steel, but we're also both part of the solution. Because there's no world possible without mobility, and there's also no sustainable society possible without steel. So not doing it is not a solution. Not moving or not using steel is not a solution, but solving the fundamental part of taking the CO2 emission out of the two. That's the crucial solution that we need to get to. And therefore, the success of the Hyperloop is so much important for our sustainable society. What are the next steps? So on the steel side, as mentioned, making sure that the steels that are ready for the time that the commercial tracks are built are based on near zero carbon steel making manufacturability is important. In the track that will be built in Groningen, it's not just a straight tube. And as you saw in the picture of HART Hyperloop this morning, it includes a switch as well. So we're still working on making sure that the switch tube and that section is meets all the demands that are there. That will be built also in the upcoming few months. And of course, the proof will be of our steel will only be once the first pods travel to the track, and we will see and we will be able to prove that the advantages and the benefits that we've promised are actually true. And that will be later on in 2023. And based on those results, of course, we will continue to develop steel grades. We'll continue to develop on the chemistries as well. But that's only one dimension to improve. And what we've also done in the meantime is give our engineers and our R&D organization much more degrees of freedom. So as Joseph just described, this is a conventional way of making a tube, which is by far the most efficient way to make a large diameter tube as we speak. But if you look at the Hyperloop, the demands are quite different from conventional tubes. So you can see a few examples of IDs that we've already developed for new configurations of tubes. And these take, as you can see, these are quite different from conventional tubes. There's a lot of thoughts behind it. We've organized also student competitions. We've had student teams in to develop prototypes from a computer-aided model, then into real physical prototypes at lab scale. And we actually have also prototypes now which are 1 meter in diameter and 6 meter long. We have destructive testing on it based on pressure, based on impact and those kind of elements. And as said before, on those requirements, we're using the same requirements on these types of tubes. It's the requirements during operation. It needs to meet all these same requirements, and its requirements during assembly as well, which may be especially important if we are changing the way the tubes are made. On this side, it is our intention and target to, by the end of 2023, when the test track has been built, one section is ready to be replaced from a conventional made tube to these kind of new prototypes. So we need to scale it up to that level in the next 18 months. So, to finalize our presentation, Joseph.
Okay, we have both developed the same grade, but under different trademarks. So for POSCO, it's POSCO, and for Tata?
It is impetus.
But if you look at how technology is developed in a certain product or industry, first you have a new grade going in, and then all structures are optimized. And then it comes to a point where it's fully optimized, then you need a new grade. For Hyperloop, we think it is time that it is necessary to introduce a steel grade that is actually for Hyperloop. So that's what we have done. It is a very unique case that a two steel mill, which we are competitors also in the market, but working together from the steel grade. That's how much we believe that Hyperloop is necessary and can give very good, can be a very good sustainable solution. Anything to add?
Well, you can see our commitment on the picture there above as well. It's the proof that we're actually, in practice, we're working on this. We're seeing each other at a regular basis to make sure that the best of the knowledge between the companies is put into this piece of steel. If anyone would like to have a closer look, you're more than welcome to meet up with us and have a closer look. Thank you.
Okay, thank you.